Hey YouTube, this is Flyfish. Just want to show you. I'm going to be constructing somewhat of an odd type of cell. I've created the red oxide layer on the inside of this piece of copper from heating it, and I have this magnesium that I've used for one of my prior cells. Now what I'm going to be doing is I'm going to have a dual cathode. So I'm going to create an area here where there's going to be electrolyte, so we'll have magnesium here, and then I'm going to have a secondary cathode on the inside, which I'm going to hook in series with this external one to increase the surface area of the cathode dramatically. So this will be the hookups just for the anode, and then we'll have an external and an internal cathode, and we're going to see what that will do as far as allowing for current flow. So we're not only going to have a very, very large internal graphite cathode, but a very, very large external copper coated with the red oxide cathode as well. So that should be an interesting experiment, and we shall see what it will do. Again, the benefit that I have here is I have a very, very thin space, which I still say is somewhat advantageous. And again, we'll have here approximately a 1/4 inch gap in this area here. And again, I'm not sure if there's any benefit to having greater volume. Again, it's a matter of the amount of fluid that can be retained versus surface area and all of this. So we're still, figuring all this stuff out as far as what is the optimal way to go. So in any event, this is just to show you how the cell is going to be assembled, and we'll go from there. YouTube Flyfish. This is just got done filling the cell. I'm going to be polarizing this in just a minute, but we can see the electrolyte. I've left little copper pieces for channels for water addition in the future. Here we have the two cathodes with the intermediary anode, and I'll polarize this in just a minute. Guys, just to show you, before polarizing, this is what the milliamp hour is according to the cell. Right now I'm just hooking it up so we can see about 300 milliamps, 350 milliamps, okay? And again, this is before polarization on the cell. And we'll look at the voltage in a second. I'm almost tempted not even to polarize this thing, but I will for just a split second to see what it turns out to be. So in any event, here is the voltage. Again, this is without polarization, about 1.2 volts at 300 milliamps. So I'm going to zap it quick, and we'll see what it shows. And hopefully it won't deteriorate the cell. Okay, YouTube, I just polarized it for a few seconds. Let's see what it's showing now from a current standpoint and a voltage standpoint. Again, this is an analog meter. We'll show what it's doing here. Whoa, that helped a little bit. It drops back down again, so the polarization is about there. So what we're showing is about a 300 milliamp hour cell right now. Okay, and let's see what the voltage is. Again, relatively nominal. I'm not that impressed, about 1.3 volts. It's rising. But we'll see what happens with this one. So at 1.4 volts. Might climb to 1.5. So, and if nothing else, again, this is just a interesting new type of cell. And again, this is fairly fresh. So I have the two cathodes hooked together with an intermediary magnesium anode. About 1.5 volts now. And again, let's just for grins check to see what the current level is. Move the voltmeter out of the way. Put the milliamp hour in here, so let's attach and let's go right here. We're still showing pushing past. Oh, that's interesting. Oh, that's pretty cool. So anyway, thought you might find this interesting. We'll see what this cell does. YouTube, it's Flyfish. Just to show you, this is one of John's oscillator circuits that I'm using. Just hooked it up to this brand new cell. Again,
just took this off. It's dried now. I'm starting to run this oscillator before everything is fully set. So I'm just going to see where this goes. Again, that thing is just like super bright. And again, from starting at around 300 and some milliamp hours, we'll see what this goes and for how long. So for what it's worth, let's find out what this is capable of doing. So, nothing else, the inside-out cell is interesting. I'm going to run this down with a load directly after fabrication, and we'll see what the effect is after rehydrating through these small cannula type spaces that I'm making on both the top and the bottom with this. We'll see what happens. But if nothing else, at least the cell design is sound. How long it lasts remains to be seen, but I'm overdriving this a bit. So,
thanks for watching.